Yeah, thank you, Diane. Welcome from my side. I'm Markus Greul from Wolfsburg in Germany. Wolfsburg is the lovely town where the beautiful Volkswagen cars are being produced and developed. So today, I would like to share our story of OpenShift, which has been moving us for around about 2 years now. Well, honestly, I'm forced to do this. Michael is responsible for it. Michael is my boss. Thank you, Michael. I'm filming. Okay. It is already on Facebook, I think. Okay. Now that I'm here, I'm going to tell you something about integration testing in the automotive industry and why this is pushing OpenShift to its limits. Or as Michael likes to say, this is really cool shit. That sounds much better in German.
Yeah.
Das ist richtig geile Scheiße. Okay, let's go on. Integration testing is one of the most complex tasks in automotive development. Why is it so complex? I'm trying to explain it to you. An electronic system in a car consists of several components. Components such as sensors, actuators, and electronic control units. Those control units contain one or more software components, and those software components, yeah, for sure, they need to interact with each other. So they're communicating via different technologies, bus systems, field buses like CAN or Ethernet, and so on. Integration testing means that such electronic systems in the car need to pass the integration testing process for each combination of components, for each equipment line of a car, and of course for each model, and this for every software version in the car. So this alone is a whole bunch of work to do, and I'm not finished. The systems itself, the more capabilities those systems gain in terms of taking over control of the car, the more test cases are needed to approve these or to pass these integration testing process. So in the end of the integration testing process, there is an approval that all systems in a car work proper, safely, and reliable for our customers. So, I need to go. Okay, let's have a look on how integration testing works in the automotive, or at Volkswagen at least. First of all, we need some kind of virtual environment. We would not test in the real world, at least for security reasons or for safety reasons. Additionally to the virtual environment, or beneficial to the virtual environment, we put a virtual car in there. A virtual car, a real car is not necessarily need to be built for just testing a subset, like an electronic system or a couple of electronic systems. To simulate the customer's interaction with the system, a virtual driver is put into the virtual car. I think I don't need to explain why the driver should be virtual as well. So the last component will be the system under test, or the test object. The test object could be a software component of an electronic control unit, the control unit itself, or a complete system, or a couple of systems which represent a customer's function. This is what we do currently in our test centers. And I think we're pretty good in doing this. But in terms of exponential growth of relevant test cases we are just facing it will not be good enough in the near future. So how can this be improved? And I think the main question is, what does all this have to do with OpenShift? Let's assume there's a test bench where all necessary components are just software artifacts running on some kind of standard server hardware. Components such as virtual environments, data analytics, other kinds of tools, test cases, test case execution applications, or simulations, traffic simulations, for example. And for sure, the software components which finally go to an electronic control unit. When all those components are instantiable software components, a test bench might be set up and being test ready in just a few minutes, compared to, let's say, weeks we would take today, we would need today.
Months.
Okay, but in terms of exponential growth, this will not be good enough. What we really need is massive scalability and automation. Instantiating fully automated test benches where we can test on request, executing hundreds of thousands of test cases without manual effort. This is where we need to go. We started around about 2 years ago of how such kind of scalability and automation can be applied to our test centers. And the idea is that those test benches, when those can be described as an OpenShift template, and those templates can be instantiated by an intelligent automating system, it is possible to fire just hundreds of those test benches automatically by the system. The system should be capable to do a proper deployment of those test benches. They should care about distribution of test cases to those test benches, executing them automatically, and for sure the system should care about proper resource claiming and cleanup. Yeah, sounds easy, right? And just because of my poor ability of explaining difficult things, I've brought a video with some impression of how we proved that this cool shit is really possible.
This will wake you up.
Yeah. Okay, let's go on.
Yeah, I think this is really awesome. And I'd like to introduce myself a little bit. I'm Martin Reinke. I'm working as a solution architect in Red Hat in Germany, a little bit more than 4 years now for Volkswagen. And I was with that journey all over the time. And I want a little bit to explain our journey until today and maybe what's coming up next. So, as Markus said, 2 years ago, we had this challenge for future testing and to really think on how we could transform that current base of technology and usage within the testing. And it is really important to be able to have this transformation in terms of having multiple test stands spin up in a matter of minutes instead of weeks or months, as we said. So back in the days, 2017, we had that first initial talk. I remember that because my technical account manager, Stefan, was coming to me, who knows those guys longer than me, and said, they have a problem, you should talk to them. So we were starting the discussion. They explained what they just explained to you. And I was thinking, this is really complex. I mean, this needs to have agility. This needs to have highly complex dynamic connections. And why not just think about having this done in containers? Oh, might be a good idea, but nobody had a clue back then if this really works. I mean, that wasn't even there that we could use GPUs. So you saw the videos that were rendered on NVIDIA GPUs in OpenShift. And back in the days, we didn't have this thing. We just had alpha code, but we proved that it worked, and we kind of done everything. So we know there is some Linux, RHEL machine code running in the systems at the R&D site in Wolfsburg. We could mix and get this up done in OpenShift. But this was not everything. So we had this technical proof, but it was more to get to this stage in terms of having real container adoption and benefits to the business of Volkswagen, as we do have it today. And so I was thinking on that picture that you see here, which is the container adoption program, one of the first pictures that are in that. And you see there a journey, how Red Hat can help customers to adopt container technology in a way that really makes business outcomes and tangible results. And this is all true except of the timing. You see there are some weeks and numbers, how long this takes. So we did most of the steps despite on the timing, because the stuff that we had to be done was much more complex and needed more time. So we proved that GPU works. We even get to a point where we really could work on other things. And there's this little red bar, this tiny red bar in the middle. So that was an important step towards the Open Innovation Lab, which Noel will talk right after me a little bit more. And this was really to get this, what you have seen as an outcome, together in a way that we really can do work together for the business of Volkswagen. So, as I mentioned, we had some challenges in terms of technical realization. So we have now NVIDIA GPUs available in OpenShift. We also work closely together with Microsoft engineers in that first POC and currently. So also Windows containers will come to that solution. But we still have a way to go in terms of new technologies, new architectures being introduced, in terms of having communication based on IPv6, as well as those field buses that Markus has mentioned before, introducing other stuff. And there are also automotive projects like AutoSAR, Adaptive AutoSAR, this Profinet thing that is mentioned here, and many more that are really helping us to help further on Volkswagen and maybe other automotive companies and suppliers in a way that really they can make their dreams come true based on our container technology. And by saying that, I think it's time to hand over to Noel.
Cheers. So they've given me 4.5 minutes to talk for stuff that took 12 weeks to build. I also don't speak German, so you'll have to keep up. So I was brought on board, let's say August last year, and told, hey, we want you to put a car in a container platform. I kind of asked, really, is it the other way around? But no, we need to get a car up and running and testing and executing within it. And yeah, it's one of those times you kind of go, how do we do that? You know, how do we start? So one thing we did at Labs is when we went in there, we started with this thing called event storming. So we sat down with the customer, and usually this event storm will take you through a solution from start to finish, or what you're going to do in that Labs engagement, and work out the major components involved. It takes about 2 to 3 days. For this, it took 2 to 3 weeks. because the Germans. Myself and Marcus here were basically, he was the product owner and I was the lead architect involved. So basically we sparred with sabers every day, it was amusing. So when you come down to it, basically it's all about constrained resources. Everything OpenShift does is about constrained resources. It's about kind of, CPU or memory or apps and all this type of stuff. What we did was basically we also figured in things like FPGAs and GPUs and everything, all this good stuff here. And which is the next button? Oh, there we go, that one. But the way we kind of looked at it is kind of, how do we actually start this up? We wanted something that could start up quickly, get this job done and clear out of the environment. So we took, Volkswagen have this concept called test environments. So we put together what they call a virtual test environment, which was 10 or 20 pods running radars and LiDARs and sensors and your virtual driver, your virtual environment, all that type of stuff. And we kind of go, right, we put this on, we'll plonk it on, and we'll shove tests at it. The thing with Kubernetes is basically it's all eventually consistent. You tell it something you want it to do, and it gets back to you when it's done. So basically, the way we actually figured this out is basically rather than setting up an environment and basically then throwing tests, we'd do it the other way around. We'd make OpenShift part of the application itself. So what we did was basically, we'd specify VTE definition, which is a whole heap of OpenShift resources, as I say, radars and data sources and all that type of stuff. We'd specify how many GPUs it could use, not just for the rendering, but for the actual calculations of collision detection and all that. You should see this video. This is the same video. We had a car doing 200 k's an hour plowing into another car, and it was hilarious. But I thankfully all virtualized. So what we did was basically, we took OpenShift, we basically created an environment, a project namespace. We patched things like multicast enabling, so that basically the components could detect each other. They use multicast to communicate and do service discovery. We basically, when they were spinning up, we prepared the test data on the other side in an asynchronous approach. And basically, when the VTs were up, ready, stable, and ready to execute, they just literally pulled across tests that had been loaded onto messaging queues. So the whole thing was asynchronous. We weren't polling, we weren't rating for stuff to get ready. It executed in its own time. So basically the whole thing was asynchronous and event-driven. We had too many events in the end because basically there was a few issues with VT restarts in the middle of testing and all that. But the thing that was important was basically using the projects as deployable units. So basically, we could run N of these in parallel, and they were all isolated. And the SDN part of that is very important for basically making sure that car X doesn't talk to car Y across the network. So the whole thing was temporal. It was all short-lived. Spun it up, executed what we needed to do. When it was all done, we shut it down and nuked it from orbit and just made the environment ready for the next set of tests that were going to come in. These VTs at the moment, we did ACC, was it? Yeah, ACC. But the VTs will be you'll have multiple types of VTs, different for collision detection, all this type of stuff. So the intention is to use a cluster as much as you need and then just get off it and let somebody else use it. So in the future, so everything we've done at the moment is about virtualizing the software components of it. In the future, we want to obtain this hardware in the loop. So hardware in the loop is basically where you have actually got hardware. Oh, we've run out of time. We've actually got hardware involved in the testing as well. So what you want to see is you want a tester sitting there, and he or she will turn a steering wheel, and the car will actually turn within the environment. So we're going to have a whole heap of fun doing that. There's as Martin said, there's IPv6, which is interesting. We're going to look at a whole heap of custom hardware, real-time compute, radar sensors that are actually detecting things in real time. We're looking at operators to drive an awful lot of this to basically simplify how people use the platform. We're looking at a thing called virtual kubelet to drive hardware nodes. We don't know if it'll work yet. It's a theory. Right? We need to figure it out. But basically, the end goal is basically everything will be managed and executed within OpenShift. So you're not having two pieces of information, floating around the place. It's the source of truth is OpenShift. We load the resource in there. It does the job and shuts down. We're looking at cloud bursting. Microsoft Azure, AWS, doesn't really matter. There's a whole heap of things going on about this because this stuff is expensive. The GPUs are lots. and basically they're hard to install. The developer workflow as well. At the moment, we're using OpenShift resources, which, yeah, they're good, but basically it's too low level for people who are developing VTs. So we're looking at custom resource definitions to specify the VTE definitions, and we're looking at operators to actually create and populate them on board. We're also looking at the glorious concept of chargeback, which is basically going to be how do we build that people are going to use this platform. So operator metering is going to come into this, we hope. But it's going to be a busy year to flesh out the end of this. And with that, I'll hand over to Marcus.
Thank you, Noel.
Hey, I got to play the video.
Okay, we just switched over. There's one shortly video left. It's just 1 minute, which I don't want to miss. Don't want to miss to show here. It is a short summary of what you just heard. Might be not that much. So please enjoy.
It hasn't got good music. Oh, it does. Sorry, I forgot about that.
There are many challenges involved when it comes to developing self-driving cars. Practical simulations and testing can be extremely time-consuming and costly. At VW, we found ourselves at a bit of a brick wall. That was until we attended Red Hat's Innovation Labs. There, we were able to create a new vision for virtual testing of customer functions in vehicles. Our new goal was to have fully automated and virtual testing, allowing us to test functions earlier in trial development, giving us greater confidence in the final product. Using Red Hat's OpenShift container platform, we're able to test and validate new features for self-driving cars through a combination of software and hardware systems, by simulating thousands of testing environments and scenarios for specific car functions, such as autonomous driving on highways, or even autonomous parking in multi-story car parks. Along with vehicle software, OpenShift's container technology helps us put all the necessary tools, applications, and simulation components in instantiable logical compounds. This helps us to run large quantities of test cases in parallel over a short amount of time. OpenShift's container technology has been vital to our success, and as a result, VW has experienced transformational outcomes, allowing us to work and think in new ways when developing, testing, and building cars.
Thank you.